Hello, Honors Algebra 1. It is Thursday, May 14th. Welcome to our very last instructional video of the year. Now, what are we going to do after the second trig lesson? Well, after the second lesson, Monday and Tuesday, I'm going to give you two review sets of 25 problems each. 25 on Monday and 25 on Tuesday, just to kind of summarize the year. They will be homework problems. They won't be test problems, so don't get nervous about that. But I want us to go ahead and get a review in since we're not going to have an exam. Okay, so before we start talking today about problem solving in using trigonometry, let's go ahead and see how we're going to use our calculator to help us with these problems. Okay, the most important thing that you're going to need to do is to start out with your graphing calculator, go to the mode key, it's to the right of the second key, go to the mode key and arrow down to where you see radians and degrees. Now, these are two different ways to measure angles. You learn about radians in Honors Algebra 2, but for this year, we want to only use degrees. And so I'm going to arrow to the right. I'm going to use my little circular arrows here and arrow to the right and hit degrees and then hit, so it's blinking on degrees and hit enter. Okay, so now I'm in degrees. Now, I'm going to go ahead and clear this screen. And I'm going to go ahead and find the sine of a 30-degree angle. Now, it'll have a parenthesis. You don't really have to close the other parenthesis. If you want to, you can. But the sine of 30 degrees is going to be, for a triangle with a 30-degree angle, the opposite side length divided by the hypotenuse. That ratio is always going to be, when I press enter, 1/2. 1/2 is going to be the ratio, or 0.5. Let's try the tangent of 45 degrees. The tangent of 45 degrees, when you have a 45-degree angle, the opposite leg length over the adjacent leg length ratio is going to be 1. Let's do one more. Let's do the cosine of 15 degrees. Now you'll notice we have this 0.5 and 1. It's not always going to be rational numbers. Let's go ahead and do the cosine of 15. Here we have an irrational number here. This is going to be, excuse me, a number that does not have any repeating pattern. All righty. Now, when we do the homework, just watch carefully. They'll tell you what to round to the nearest tenth, to the nearest hundredth. So we'll just have to be careful with that. Okay, so that is how we find the sine, cosine, and tangent of specific angles in degrees. So remember, on mode, make sure that you are in degrees. If you're not, you'll be in big trouble. Okay, now let's go ahead and learn about how we're going to apply this. So this is pretty cool. I'm going to have my calculator ready here because we're going to have to use it to calculate with sine and cosine and tangent. All righty. Now, let's go ahead and remember our SOHCAHTOA. Sine is opposite over hypotenuse ratio. The cosine is going to be the adjacent leg over the hypotenuse ratio. And the tangent is going to be the opposite leg length over the adjacent leg length. Okay, so there we go. Now, let's look at this word problem. This word problem kind of made me sad because it's talking about and you're over here 166 meters from a building, and the building is over here. You can't see it, but this X represents the height of the building, and they're talking about the World Trade Center, so which doesn't exist anymore, of course, in New York. So made me a little sad to read this word problem. It's the first one in the section that you're going to do homework on. Okay, so if I'm standing 166 meters away from the edge of the building, and I'm looking up at the top of the building at an angle of 68 degrees, okay, at an angle of 68 degrees, I can find the height of the building. I can find the height of the building, okay? So if this angle is 68 degrees, this distance is 166, what is this measurement? Now let's think about what these things are in relationship to our angle, okay? Now, the angle is right over here. the opposite, these are both legs. X is the opposite leg, 166 is the adjacent leg. The hypotenuse, we don't even really need, okay? We don't really need the length of the hypotenuse in this problem. We're just trying to find the length of the opposite leg. Now, what you have to do is you have to decide what trig ratio am I going to use to solve this problem. Well, what are the two sides I have? I have the adjacent leg, and I'm looking for the opposite. So I'm talking about a ratio with adjacent and opposite. Well, let's look up here at SOHCAHTOA. Tangent has adjacent and opposite. So I'm going to use tangent, and I'm going to write an equation. Now look what my equation is going to be. The tangent of my angle. So I'm taking the tangent of 68 degrees is going to equal the opposite length, opposite leg length, which is x, divided by the adjacent leg length, which is 166. So I have a simple equation here. How do I isolate x? I isolate x by multiplying both sides by 166. Now, so I'm going to get x is equal to, put 166 before you put the tangent of your angle when you are writing this and when you're entering it into your calculator. So every 68-degree angle is going to have the same opposite to adjacent ratio, okay? So that's why this is going to be in the memory of your calculator. It has all of these ratios embedded in your calculator, which is so handy, okay? The book has a table at the back, and when I was in high school, I had to use a table because I didn't have these calculators with this kind of memory. But we do now, so we're going to use it. Oh no, there goes my cat. Okay, so get your calculator out. Let's do it with me. We're going to go ahead and multiply 166 times the tangent, so hit your tangent key, and then hit 68 degrees and hit enter. And there it is, okay? I'm getting 410.8644. Now, it tells me to give the height to the nearest meter. So I've got 410.8. So that gives me an approximate height. I'm going to make that a little approximate instead of exactly equal to 400, not 10. I'm going to round it up to 411 because it was 0.8. It's 410.8. Okay, now this is meters. And so the height of the World Trade Center was 411 meters. Okay. Now, let's move on to another one. Let's try this one right here. Okay. Let me move this right over a little bit. Okay. Now, what do I have here? I have a 42-degree angle, and then I also have two side lengths. One is known, one is not known. Now, in relationship to this angle, what do I have? I have the opposite leg. I do not have the adjacent leg. I have the opposite leg, and I have the hypotenuse. So let's go ahead and think, what trig ratio, SOHCAHTOA, where are you? SOHCAHTOA, what SOHCAHTOA, which one of those, SOHCA or TOA, involves opposite and hypotenuse? Well, it's sine. And so I'm going to write an equation again. The sine of 42 degrees is equal to the opposite 58, opposite length, okay, opposite side length over the hypotenuse. Now, this one's a little bit more challenging to solve than this one because this one, I just had to multiply both sides by 166. This one has x in the denominator. Oh, I got to get that out of the denominator. So the first thing I'm going to do is I'm going to multiply both sides of my equation by x. So to do that, I'm going to end up with x times the sine of 42 degrees equals 58. Okay, I'm almost there. So what does x equal? Sorry, I'm in the reflection zone. X is going to equal 58 divided by the sine of 42 degrees. 58 divided by the sine of 42 degrees. So let's go ahead and see what that is. 58 divided by the sine of 42 degrees gives me 86.67. Well, let's go ahead and round that to the nearest tenth. I've got 86.7. So x equals 86.7. 46.7. We won't use units on that. We'll just, I think it was a word problem here, but we're just not going to worry about that. Okie dokie. Now, let's go to one more. Let's do one more. So far we've used the tangent and we've used the sine. Let's see what we need on this last one. Now, I made this one, I picked this one because the triangle was kind of turned all around, but you have to still be able to recognize where your legs are and what your hypotenuse is. So, of course, my legs are my two sides of my right angle, and here's my hypotenuse is 70. So I know that I have the hypotenuse. Here's my angle 48. Well, the unknown side I'm looking for, is that the opposite or the adjacent leg? It's the adjacent leg, okay? It's right there next to it. Remember, the hypotenuse is never a leg. The legs are going to be the adjacent leg is right next to the angle. The opposite leg is over here. So I have the adjacent leg and I have the hypotenuse. So which of my SOHCAHTOA uses adjacent and hypotenuse? So, C-A-H, cosine, adjacent over hypotenuse. So, here we go. Let's go ahead and write that with the cosine. So, the cosine of 48 degrees is going to equal my adjacent unknown leg over my hypotenuse, which is known to be 70. Now, let's go ahead and round this one. Let me turn off my light here, sorry. Let's round this one to the nearest tenth also. So I'm going to say x is equal to, multiply both sides by 70, 70 times the cosine of 48 degrees. Let's do this one to the nearest tenth also. All righty, 70 times the cosine of 48. 70 times the cosine of 48 is 46.839. So I've got x equals 46.8. I'm going to just do 46.8 to the nearest 10. Okay, and that is how we use our sine, cosine, and tangent to find missing side lengths when we have one angle, that's all we need, an angle other than the right angle, an angle, an acute angle, and a side length. So it's going to ask you, oh, it's not going to tell you. Let's see. Oh, okay. On some of the homework, it's going to say find the value to the nearest whole number. Okay, I see whole number and whole number here. And then just be careful. I gave you some word problems. Let's see. Distances to the nearest whole number. So we're going to round everything to the nearest whole number, looks like. So just be careful on that. You can also find angle measurements, but we're not going to do that this year. I'm not going to push it. I just want to introduce you to finding side lengths. But next year, we'll also use Trig to find angle measurements when we know two sides, which is pretty cool too. All righty. So this is our last video. So if you don't come to Zoom today, I won't really have any more interaction with you except on the class wall or through email. So we'll finish this up, and this will be due on Monday morning, and then Monday and Tuesday we will have 25 multiple choice problem review sets just to tie everything together from the whole year. So I hope you have a great Thursday and a blessed weekend, and I'll be with you at Zoom, or I'll be communicating with you through the class wall on Monday and Tuesday. Bye-bye.